So yeah, we will start another session of relative motion. So in last session, we studied about the basic concept around relative motion. That what is relative motion? What is the meaning of motion of one particle with reference to other particle? Everyone? Yeah. So I'm just unmuting you. Okay, everyone. So we'll discuss the application of what we have studied and we'll solve some more problems. Okay? Message to host, yes. Message to host. Okay, everyone? Right, ready? Okay. So start with this first problem. Just go through this first problem. Everyone? Now we have xt curve, a graph between displacement and time. So we know that the slope of xt curve, displacement time graph, gives us what? Tell me. It gives us what? Anyone? Slope of displacement time graph gives us what? Guys, message to host. Everyone, message to host. I've changed the host. Okay, I've changed the host. Okay, yes. So it is actually velocity. Okay, it is velocity. It's not acceleration. It's velocity. You should be very clear with your basic concepts. So slope of distance time graph will give us velocity. Okay, now just think about this. We know that what is slope? Slope is nothing but tan theta, right? Yes, everyone. Okay, or it is basically the inclination with respect to x-axis. Now tell me, which of the two will have higher velocity, right, or higher speed, A or B? Tell me, which of these two will have higher speed, A or B? B, right? Because slope of B is more than that of A. Yes, slope of B is more than A. Okay, any issues? Okay, so let's see. Choose the correct entries in the bracket below. After observing this graph, let's choose the options. First, lives closer to school, then B. Okay, so where is school? This is school. This is your school, right? And this is, tell me, this is your school. Okay, and this is what? This is the distance from the school to their homes. Now tell me, out of this first one is quite easy, right? Who lives closer to school? Obviously A, because it is P, right? A lives closer to B than B, sorry, closer than B, right? Okay, so it's easy. Now B, tell me, dash starts from the school earlier. Now who starts earlier, A or B? Who starts earlier? No, na. See, A starts at 0 time, time t is equal to 0, and B starts after some time. So who starts early? A, na? Or B? A, right? Got it? A. See, very simple problem, right? C, C. Dash walks faster than Dash. Now, who walks faster, A or B? See, Navya, see this, right? This journey of A starts at time t is equal to 0, right? Because the slope starts from 0, which means journey of A starts from time 0, whereas journey of B starts after some time. Okay, got it? It's not about fast, na, right? They're two different things. Being fast and starting first is actually two different things, na, right? Got it? Okay. Now, who is faster, A or B? That we have already discussed. Okay. I guess everyone know. Yes, B is faster. Okay. Now, D. A and B reaches home at same time. Tell me, yes or no, or different time? Same time or different time? Different time, na? Yes, very good. So A reaches at this time, whereas B reaches at this time. Okay. Because message at host. I have changed the host. So message at host. Okay. Now E. Who overtakes whom? Who overtakes whom and how many times? Tell me. B overtakes A. B overtakes A, right? Once or twice? Once. Very good. So B overtakes A once, right? Yes, very good. So I guess it's easy. You got the idea? So let's solve some more numerical problems. Okay, right? Just go through question number 2. Everyone, just go through question number 2. Okay, so see question number 2. I guess everyone can see the question number 2, right? So I told you, whenever we have to solve some problem, first of all, write down all the information. Okay, so let's see. We have already solved a problem like this. Yes, everyone? Yes, Janvi. Right? It's easy. It's fairly easy problem, right? So two trains of length A and B having length 200 meter and 300, right? Respectively. They are moving in same direction. Just think about this, right? So how long will they take to cross each other? Okay. So you have to find first. So you okay, everyone? Can you hear me? Yes. So you have to find, see what you have to find. Okay, you have to find velocity of A with respect to B. So this is velocity of A with respect to ground minus velocity of B with respect to ground. Yes or no? Tell me. Yes or no? Can I use this directly, or should I have to write plus velocity of ground with respect to B? Then we have to substitute velocity of ground with respect to B is negative of velocity of B with respect to ground. I hope all of you remember this, you understood this, right? Now, it is said that both are moving in same direction. So, velocity of A with respect to ground, if it is 30 I cap, then velocity of B with respect to ground is also 20 I cap, okay? Why? Because they're moving in same direction. Got it, everyone? Tell me, got it? So velocity of A with respect to B is equal to what? 30 minus 20, 10 I cap meter per second. But here you just have to talk about the value. Okay? So magnitude of VAB is equal to 10. And distance. What is total distance? Tell me. What is the total distance covered by both A and B? Tell me, everyone. What do you think? What would be the total distance? It will be 500 meter. Yes, very good. Very good. So time is equal to distance by speed. So it will be 500 by 10 meter per second. Sorry, 10 meter per second divided by meter. So it is seconds. As simple as that. So it's 15 seconds. 50 seconds. Okay, everyone? Easy? Tell me, are you getting the hang of this? Easy? Yes, because we will add now, right? If train has to cross each other, then the total distance covered should be sum of both, right? Okay, let's solve another problem. Let's see. I hope you can solve now. Okay, let's solve another problem. Everyone, can you see the problem now? Prahlad, we have discussed one problem, okay, in last class when they're moving in opposite direction. In that case, it will be added now, right? In that case, we will add the velocity. Now, where VAB is equal to VA with respect to ground, right? Plus V ground respect to B, as simple as that. But V ground respect to B can be said as minus of V, B respect to ground, right? That's what we have written. See the first statement. Okay? Okay. So everyone, please try this problem. Please go through this and try to solve this problem. Step by step. Okay, step by step. Because physics is all about conceptualization of your problem. Okay, so let's figure it out what is being asked in this problem. A man can swim a distance of 6 kilometers down the river, right? So this is your down the river means downstream. Yes or no? So speed of river, speed of river, speed of river in downstream. Right? Okay, no, speed of man, sorry, not river, speed of man in downstream, right? Yeah, Janvi, speed of man in downstream. Okay, it is given speed, a man swimming distance of 6 kilometers down the river in 20 minutes, right? Tell me, so what is the speed of man in downstream? Tell me. 6 kilometers in 20 minutes. 6 kilometers in 20 minutes. So it will be 6 divided by 1 by 3, which is 18 kilometers per hour. Yes or no? 18 kilometers per hour. Yes? And same speed of man in upstream is given as what? 6 by 30, which is your by 60. 12 kilometers per hour. And we know that. Let's suppose speed of man with respect to ground. Speed of man with respect to ground. or velocity of man with respect to ground? Better. Better to say velocity of man with respect to ground. Let it be x. Okay. Or velocity of river with respect to ground. Let it be y. So this will be, when you talk about downstream, it will be x plus y, right? And this will be x minus y. Got it, everyone? So you got linear equation, two variables. Just add them. 2x is equal to 30, x is equal to 15 meter per second, right? In the same way, y will be, just put the value, 3 meter, sorry, it's kilometer per hour. Everything is in kilometer per hour. So it will be kilometer per hour. Kilometer per hour. Okay. Okay. Okay, Prahlad and Vaishnavi. Right, Navya. Let's see what you're not getting. First of all of you used to solve linear equation to variable, right? Now just think about this. Just think about this. Let's understand what is upstream and downstream. Okay, let's understand what is upstream and downstream. So first, let's visualize. Suppose we have a river. Suppose we have a river and you're just swimming here, right? You're swimming. Okay. Now, if river is not flowing and your speed is 5 kilometer per hour, right? Case 1. This is your speed with respect to ground. Velocity of man with respect to ground is 5 kilometer per hour. Yes or no? This is the information which I'm giving. Okay. Now in second case, river is flowing in this direction. Okay. And the speed is 3 kilometer per hour. So velocity of river with respect to ground is 3 kilometer per hour. Okay, everyone? Tell me. Okay, everyone? Right? Okay. So tell me, what will be the speed of man with respect to river? Tell me. Speed of man with respect to river. क्या होगा? No, that's wrong now. Right? No, Vaishnavi. That's the concept. That's the misconception. Yes, Abhay, very good. Very good. Yes, Shirsha, very good. Right? So see, right? You have to visualize. First, let's see mathematically. It will be velocity of man with respect to ground plus velocity of ground with respect to river. Your basic formula. It's not in formula, it's a basic concept. So which is velocity of man with respect to ground minus velocity of river with respect to ground. Yes or no? Tell me, yes or no? Yes or no? So this will be 5 minus 3, which is 2 kilometer per hour. Makes sense, na? Makes sense. Now just imagine if this person is not swimming, he's just there, right? He's not doing anything. Will he be stationary? Tell me. Will he be stationary if he's not swimming? Will he be stationary? Yes or no? No, na, because river is already flowing. River is already flowing. Okay, so if river is already flowing, so he won't be stationary. At least he will flow with river. Yes or no? Tell me. Yes or no? Right? Okay. Now, if he's swimming also, right? So it depends on in which direction. If he is swimming in the direction of the river, right? So his total speed as seen by the observer, as seen by the observer on the ground, right? Suppose this is the observer in the ground, right? With respect to this, the speed of this person would be more, right, than the speed of swimming. Yes or no? Because you will add both speed of river as well as speed of, tell me, man, right? With respect to river. Got it, everyone? Just imagine, just imagine. Prahlad, what is the meaning of velocity of ground with respect to river? Will ground move with respect to river? If I'm saying 3 km per hour, it is the velocity of river with respect to ground or ground with respect to river? Tell me. River with respect to ground, right? But when you talk about this formula, it's not even formula, it's basically the relative motion. Velocity of A with respect to B is equal to velocity of A with respect to C plus C with respect to B, now, right? As simple as that. So velocity of M with respect to R, which is man with respect to man with respect to river, is velocity of man with respect to ground plus ground with respect to river, right? Got it? But we have given river with respect to ground, so we know that velocity of ground with respect to river is negative of, right, because it's opposite direction, as simple as that, right? River with respect to ground is equal to negative of ground with respect to river. Got it, everyone? Right? Tell me, got it? Yes? So now you got, so tell me, this is the case of upstream or downstream? This is the case of upstream or downstream? Tell me, this is the case of upstream or downstream? Downstream, yes. Downstream means along the river, downstream. Okay, right? Now just think about another example, right? Just think about another example. Suppose I have given you velocity of man with respect to river, okay, as 15 km per hour, and velocity of river with respect to ground, okay, as 3 km per hour. Find velocity of man with respect to ground. Tell me, velocity of man with respect to ground. Easy? Now it seems easy, right? Got it? Just see the second equation, BMR. So this will go this side. So velocity of man with respect to ground is velocity of man with respect to river plus velocity of river with respect to ground, right? You will just take this term to this side. Got it, everyone? Tell me. So it will be velocity of man with respect to river. Okay, see this plus, sorry, velocity of river with respect to ground. Yes or no? See this term? Yes, everyone? Tell me. Are you getting this concept? Right? See this? Man with respect to river, river with respect to ground. We'll was not audible. Wait for some time. I got a call. Okay, I guess it is audible now. Right, everyone? So all of you know the concept. Okay, everyone. Now, I think it is fine. It should not be cracking now, right? It should not be cracking now. Okay. Yeah. We will solve more problems. So this you understood? Now you understood why in downstream it is x plus y and in upstream it is x minus y. Okay, where x is the speed of man with respect to river and y is speed of river with respect to ground, right? So here it is wrong. Sorry, my bad. X is velocity of man with respect to river. Okay, right, everyone? Right? My bad. So just go through this problem. We will try to solve another problem. Okay, let's see this problem. Another problem. 613. What is 613 now? Where is 613? This is 6 is distance divided by 20 minutes is 1 by 3 are na? Distance by time. That's it. Distance by time. So 20 minutes is 1 by 3 are na? Got it? Right? Okay. Okay. So let's see this problem. Let's see this problem. Right? This is question number 4. Just go through this problem now. Now tell me, just think about this. When you throw two objects, just think about this. When you throw two objects, if they collide, suppose if they collide, right? So what can be said about its velocity? At the time of collision, at the time of collision, what can be said about the velocity? Yes, very good. Now, this is not the final velocity, it is relative velocity. Got it? The relative velocity of A and B, right, is 0. Yes or no? Forget about everything. Forget about big concepts, conservation of momentum and all those things, right? Just think about this now. Just think about this, right? If we have object A here and object B, so object A is thrown, then object B is thrown, right? So A will have some velocity with respect to ground. So velocity of A with respect to ground. Now B is also having some velocity with respect to ground. Yes or no? Got it? Right? Yes or no? Tell me. Yes or no? Okay. So if it's a constant velocity with respect to each other, if the velocity, right? Now I can say that if they will both, just think about this. Sorry, forget about velocity, right? If they will both cover the same distance, yes or no? Same distance in same interval of time. That's the meaning of collision. Yes or no? Yes or no? There are two approaches, one without relative motion and one with relative motion. Okay, so if you even think without relative motion, right? So you can say that they will collide, okay, when they are at same position, right? Or obviously at same time. Yes or no? Tell me, yes or no? Okay, now this is just example. This is just the concept. I'm not talking about this problem. I'm just talking about concept. Now in this problem, they both A and B are not thrown at same position. A is thrown from downward and B is thrown from upward. Okay, so it's like this. Wait. So it's like this. We have 40-meter high tower, and this is 40 meter. So from here, B is vertically thrown downward. Okay, and from here, A is vertically thrown upward. Anyone have any issues? This is A, this is B. Anyone have any issues? Tell me. Anyone have any issues? No? Okay, very good. Now this is your distance. This is your distance, which is 40 meter, right? 40 meter. Now, obviously, A and B will collide at some point. Tell me, yes or no? A and B will collide at some point. That's the speed, na? Navya, just see this, na? This is your speed, right? 20 meter per second is the speed of A. Okay, got it? So just think about this. Write down all the information first. I hope all of you understood what is happening. That's the first part of solving any physics problem, to imagine what is happening. So I hope everyone imagined what is happening, right? Everyone observe what is happening. Yes, tell me. Tell me, was it difficult to understand what is happening? All of you understood what is happening? Okay, okay. Now it is said, just think about this, just write down velocity, right, of A with respect to ground. Okay, right? A with respect to ground is again 20 meter per second. Okay, in the same way, velocity of B with respect to ground is also 20 meter per second. It is given. It is given same speed along the same line of motion. The only difference is velocity of A to B is in upward direction. So plus j cap, right? Plus j cap. And this is minus j cap, right? I'm just writing the direction over here. Got it? Wait, ulta लिख दिया मैंने. Yeah. So A with respect to ground is j cap and B with respect to ground is minus j cap, right? B ऐसे आ रहा है ना, A ऊपर जा रहा है. Got it, everyone? My screen is visible, Puneet? Everyone? Is my screen visible? Tell me. Is my screen visible? Tell me, everyone. Is my screen visible? Okay. Now tell me, what will be the speed of A with respect to B? What will be the speed of A with respect to B? Respect to B? Yes, very good. Very good. Right? So just write like this. Velocity of A with respect to B is equal to velocity of A with respect to ground minus velocity of B with respect to ground. Yes or no? Tell me yes or no. So velocity of A with respect to ground is what? It is 20 j cap, right? And velocity of B with respect to ground is minus of minus 20 j cap. Yes? So this will be 40 j cap. Anyone have any issues? Tell me. Anyone have any issues? Yes or no? Velocity of A with respect to B? Okay, very good. Very good. Now just think about this. Just think about this. What is happening over here? What is happening over here? This distance is when they collide. This distance, the distance covered would be what? 40 meter? Yes or no? When they will collide, net distance traveled by both A and B will be 40 meter. Yes? Yes, everyone? Tell me, yes? Anyone have any issues in this? Okay, very good, very good, very good. So let's see. So I can say that S is equal to U relative T. Relative velocity use हो सकता है half A relative into T square. Yes or no? Tell me. S is equal to U relative into T plus half A relative into T square. Tell me. Yes or no? Now try to figure out. Try to think first. Okay? Take some time. Try to think. What would be the answer? It is relative, Navya, right? So when you talk about relative, when you talk about relative, just sit on A and observe B, okay? Or sit on B and observe A. That's meaning of relative. And I have just written the equation. I have not assigned any sign, okay? So that's you have to figure, okay, that what would be the sign. See, this is a conceptual problem, okay? Just a conceptual problem, right, everyone? We haven't written any big equation, okay? We haven't written any big equation. You have to find, first you have to find time now. First find time, okay? Try to find time first. Okay, let's see. Now, U relative is, tell me, 40? Any issues? U relative is 40. Yes or no? U relative 40, right? S 40. So just write this. 40 is equal to 40 into T plus. Now, what is A relative? Just think about this now. Just think about this. Acceleration of A with respect to B is equal to, now acceleration of this with respect to ground is positive, whereas this with respect to ground is negative. So overall acceleration with each other would be zero because both are having same force now, right? Both have same force, right, everyone? Everyone, you can hear me? Yes, you can hear me now. Okay. Okay. Now just think about this. It will be half into 0 into t square. So t is equal to 1 second. Means they'll collide in 1 second. Right? Now if you see this problem, there's nothing much to solve, but it is conceptual. Yes or no? Tell me, is it conceptual? You don't know V, na? Final velocity at the time of collision, we don't know, right? Got it? See, Navya, what is acceleration of A? Tell me, what is acceleration of A? G, right? So I can say that acceleration of A with respect to B is equal to acceleration of A with respect to ground minus acceleration of B with respect to ground. Yes or no? Tell me. Same relation. Yes or no? But both are having acceleration same, na, gravity, and both have same direction of acceleration in negative direction or positive direction, doesn't matter, right? So it will be 0. Okay, everyone. So this is your time. The question is asked, what is the distance covered? Okay, right? See this. It is asked, at what point do they collide? So you have to find this distance, right? No, Prahlad. It is direction of acceleration, na? Just think about this. If a body is moving upward or downward, but acceleration is always in one direction, acceleration due to gravity is always in downward direction, that you agree or not? Right? So that's why you have to think like that. Okay? So yeah. So this distance in red is distance covered by A. So SA is equal to UAT plus half AA T square. Yes or no? So it will be, tell me, 20 minus half into 10 into 1 square. Because for A, acceleration is in downward direction. The answer is 15 meter. Got it, everyone? Tell me, got this? Even if you understand one or two problems, but these are very good problems. Try to figure it out. Just think about it. Think about it. Okay. Think about it. Right? What has happened? Because all the equations that we have used, right? All the equation that we have used is basic equation that we have studied. Yes, Vaishnavi. That's what we can say. 15 meter above the ground. because last step is just second equation of motion. Question पढ़ो ना. Prahlad, read the problem. Read the problem. What is being asked? Just read the problem first. Right? What is being asked? You are asked to find the point at which they will collide. Yes or no? Tell me. Yes or no? So obviously, if they will collide at 1 second, after 1 second, so there must be some distance covered by A 1 second, right? And there must be some distance covered by B. So see, this is method 1. Okay. This is method 1, using relative velocity. Okay. The second method, which I was explaining. So first, I hope all of you understood method 1, right? How can we use relative motion? Okay. If you understand this, if you understood what is the application of relative motion, then it is easy. There is second method also. What is the second method? Right? So second method is bit calculative. What you have to do? You have to find the distance covered by B in t second, distance covered by A in t second, right? Now since time taken would be same, okay, so SA plus SB should be equal to 40. Method 2, I'll just write method 2 over here. Method 2. Method 2. This question can be asked in your Olympiad without even using relative motion, right? So can you say that at this point, if they are colliding at this point, okay, sum of total distance is 40. Tell me, if they're colliding, then distance traveled by A plus distance traveled by B should be equal to 40. Yes or no? Tell me, should be equal to 40. Now there, if an object is moving in upward direction, what will be the acceleration? Tell me, Navya. If an object is moving in upward direction, what will be the acceleration? Will it be plus g or minus g? Will it be plus 10 or minus 10? Minus g, na? That's why it is minus. Okay? No, Navya Shastri, not Popri. Okay? Got it? Right? So see, second method. So we know that SA plus SB is equal to 40. So what is SA? It is UA into T plus A T square by 2 plus UB T plus AB by 2 T square, because time would be same. Okay, and this should be equal to 40. As simple as that. So after solving this, you will get equation of time. Solve this, put the value, you will get this. This is your method 2, right? But again, this is your lots of calculation. Okay, this is your lots of calculation. Okay, everyone. But this kind of problem may be asked in your exam. Okay. Janvi, it will be uploaded on the YouTube. Don't worry. It will be uploaded on the YouTube. I've already uploaded the first class on YouTube. Okay. Just watch it after the class. Okay. So I guess all of you understood method 1, method 2, both, right? Understood the concept of relative motion, how it is used. In physics, it is the application which you have to learn, not the formula, right? Now that is the basic difference. Okay, that is the basic difference between conceptual understanding and just mugging up some formulas. Okay, right? So you have to imagine, you have to think what is happening. Okay, right? And let's see one simple problem. Let us solve one simple problem now. Okay, I will give you a simple problem. Don't worry about that. Okay, can you see the problem? Tell me, can you see the problem now? Right? This is one simple problem. Try solving this. This will be last problem of today's class. See how time just went by. Okay. No, well, I won't send that module. Okay. But please go through the book. Okay. Please go through the book. Because that module we will complete in next year. Okay. You just have to go through the book that I have uploaded. Okay. Lots of examples plus theory, everything is given in that. And please make the habit of reading books. If you have any doubt, we will have a doubt solving session from that book. Okay, right? So I request for physics, you should follow that book only. Okay, stick with one material, right? So whatever I'm doing, vector, yeah, vector is not there because it is, the application is there in motion in plane. Okay, motion plane. Vector I've already shared now. Vector I've already given. Okay, so don't worry about that. So solve this problem. Everyone solve this problem, right? Vaishnavi, this is, see, I will suggest, right? I don't recommend guides, okay, except for social science, Hindi and English, okay? Reference book, I have already shared the reference book. Have you seen the book? Tell me, how many of you actually gone through the book? It is uploaded on Google Classroom. It is a detailed book, okay, right? Everything is given in detail. If you go through the book, everything is given in detail. Okay. Yes, Ashila. It's actually a very nice book. Okay, I would request you guys, if you are actually interested, okay, you can solve extra problem from that. I will keep one extra class, a part of these classes, right? If you need, if someone, I don't think that most of you will do that, but even if 4 or 5 students will do that, I will have one extra class for that problem solving. Okay, and that will just discuss the problem. You have to ask doubts. Okay, if you talk about that exercise, okay, so they are solved examples plus at the back of the exercise, even if you don't solve numerical problems, just go through all the objective problems. Okay, just go through all the objective problems. Your concept would be very good. Okay, how many of you actually what is given? A rocket of length 17 meter is going up with constant velocity of 8 kilometer per second. Okay, how much time it will take to cross window? Okay, with vertical length of 3 meter. Okay, tell me. What should be the total distance covered by the rocket? Tell me, what should be the total distance covered by the rocket? Anyone? Okay, it is something like this. Yes, everyone? Yes, Ashila, very good. Right? It is something like this. Yes or no? It is something like this. So the distance, this distance is your 17 meter, and this is your 3 meter, sorry, 3 meter. Now this rocket will cross this, okay? Wait, there's some mistake that I did, I guess. Okay, yeah. So when this rocket, wait, just, guys, am I audible? Because I think that my voice is breaking. Just tell me, am I audible? My voice is clear. Okay, very good. Right? So see this. Sorry, window is not here. Okay, window is somewhere here, right? Somewhere here. It's like this. Okay, so see, when this rocket will cross this window, so it will start crossing when the tip is at the bottom point, right, of this window. Yes or no? And when it will cross, the bottom part of the rocket will be at the top of the window. Yes or no? Right? So total distance should be 17 meter of the rocket plus 3 meter of this window. Yes, very good. So total distance, T total is equal to 20 meter, right? U is equal to 8 meter per hour, right? So 8 kilometer per hour. So you have to convert into meter per second, right? Got it? Okay. Sorry, this is misprint. This is 8 meter per second because kilometer per second, it's wrong. Okay, right? So yeah, it is 8 meter per second. It is mistake. It is printing mistake. It is 8 meter per second. 8 meter per second. Okay, so you know that, right? Time is, sorry, distance is given and velocity is given. Can you find, yeah, time? Can you find time? That's what it is asked, right? Easy. Okay, so time is distance by speed. Very good. So 20 by 8. So this is what? 2.5. Okay, sorry. My bad. It is not printing mistake. I guess it can be written. It's fine. It can be written like this. 8 kilometer per second is correct. It is 8 into power 3. Sorry. I don't think that it's wrong because kilometer is also used, right? It's usually kilometer per hour, meter per second. That's why I thought it is meter per second, but it can be kilometer per second also. No, it is just 8 into 10 power 3 meter. Kilo is just used as subscript, right? So 8 kilometer per second is 8,000 meter per second. So it will be 2.5 into 10 power minus 3 seconds. Got it, everyone? Tell me, because it's a rocket, right? So it makes sense that it should be this fast. Okay, got it, everyone? Tell me, got this? Yes or no? Right, everyone? Okay, okay. So I hope all of you understood the basic concepts of relative motion. Yes, basic concepts of relative motion. So I'll show you what you have to study. Okay, now one more thing, because the topics that we'll be covering from now onwards will be like this only. We'll be having lots of problem solving. See, 1 hour is just finished and we have solved only 4 or 5 problems. Okay, so it will take time. So what I'm thinking is, can we have this uh, 2 hour session on Sunday only, like at stretch? Would it be fine? You will get longer time to solve also, right? It's better, right? Okay, so If no one have any issues, so we will have Sunday only 2 hour session. Okay, because 1 hour is not sufficient now. Okay, 1 hour is spent in just teaching something, then 1 hour is spent in problem solving, and problem solving is being done on second day, then there's issues.